there's some properties that logs have that can help us when we're working with derivatives of logs. So logs, remember, are exponents, and so they have the properties of exponents. So let me walk through what some of those properties are so you can see. First off, when we write the log base b of m, we're talking about the exponent that you put on b to get m. So in other words, whatever this number is, if you make it the exponent on b, then you'll get m. So another way of writing m, if it's a positive number, is as b to the log base b of m. Now, one property that exponents have is that when two numbers have the same base and you multiply them, you add the exponents. What that means for logs, if you want to know what's the exponent that goes on the product of two numbers, it should be the sum of the two exponents. So again, the exponent on the product is the sum of the exponents, just like this exponential statement. We could actually prove it if we think about it this way. The log base b of m times n, if m and n are both positive numbers, then they could both be written as b to some power. M would be b to the log base b of m, and n would be b to the log base b of n. We're multiplying inside this log two numbers with the same base, so we could add exponents. So we'd get b to the log base b of m plus the log base b of n. Now when you're asking about the log base b of b to some number, you're just asking what exponent do I put on b to get b to this particular power. Well, obviously it would just be that exponent, right? So we have the log base b of m plus the log base b of n. So that shows that the product of the log of the product is the sum of the logs. That's the product rule for logs. That means if you're working with some expression, maybe you're talking about the log of x plus 3 times the log of x squared minus 4, you could always rewrite it using this as the log of x plus 3 plus the log of x squared minus 4, since the log of the product is the sum of the logs. And you have to be a little bit careful because if there's a variable in here, then there might be times when x plus 3 times x squared minus 4 is positive, but the two individual pieces are not. But for the most part, we can get through it just by separating. So we can turn the log of a complicated thing into the log of something similar. Now, another property that exponents have occurs when you divide them. If you take b to the x and you divide by b to the y, we know that that's b to the x minus y. So what that means for logs, if you want to know what exponent you would put on the quotient, then you would just take the difference of the two exponents, right? The exponent of the quotient is the difference of the two exponents. So that would be the log base b of m minus the log base b of n. Now again, we can see why that's true, because if m and n are both positive numbers, then m could be written as b to the log base b of m, and b to the log base b of n would be the same thing as n. So now we're dividing two numbers with the same base, so we get the log base b of b to the difference on the two exponents, difference of the two exponents. Okay, and this is saying what exponent do you put on b to get b to this particular power? Well, that would be the exponent that you put on b to get b to that power, so that's the log base b of m minus the log base b of n. So this is sometimes called the quotient rule for logs. It's not a derivative rule, right? It's just a rule for working with logs. We have a different rule for the derivative of a quotient. We're just talking about a property that logs have. Of course, it just follows from this property that all exponents have, right? The exponent of the quotient is the difference on the exponents. Another property that exponents have is if you have b to some power, and then you raise that to a power, then you just multiply exponents. So the log on the power is the product of the exponents. Let's see what that would mean for logs. Let's say we're taking the log of m to the p. Well, that would be we're going to take the log base b of m, but we could write b, if m is positive, we could write it as b to the log base b of m, because this is the exponent you put on b to get m. We've put that exponent on b, and so this is the same thing as m. And then we have that thing raised to the pth power. But this rule for exponents says you multiply exponents. And so we get the log base b of, we just multiply these two, b to the p times log base b of m. I can multiply in any order, so I just put the p in the front. So basically all I've done is just to multiply those two exponents, because that's what you're supposed to do when you have a power of a power. Now this is just saying the exponent you put on b to get b to this particular power, which is of course that power, p times the log base b of m. So what we can see is that we had the log base b of m to the p, and we brought the power down in front essentially. It's the same thing as p times the log base b of m. Alright, that's the power rule for logs. So that's an important property of logs. One last property that we can show for logs is what's called the change of base rule. Let's say we want to find the log base a of some number m. So we want to figure out what that is. So we know that m could be written as a to the log base a of m. We also know that m could be written as b to the log base b of m. So depending on the base you use, the way this appears will be different, right? So let's do this. We're going to say that we could have the log base a of m, but that would be the log base a of b to the log base b of m. Now from our power rule, we know that when you have the log, it doesn't matter what the base is, of some number to a power, that power can come down in front. So we get this, the log base a of m is equal to the log base b of m times the log base a of b. This gives us a formula for converting bases, because if I divide both sides by the log base a of b, I get this. I have the log base b of m, that's what we have right here. Getting that alone, I have the log base a of m divided by the log base a of b. So this is called the change of base rule. Now in calculus we tend to prefer the natural log, so most of our problems will involve the natural log base e. But if we happen to have a problem that has some base that we're not familiar with, we could always change to base e by following this formula, right? If you want to use a different base, then you can take the log of your number in that different base, but you have to remember to divide by the log in the new base of the old base. Now, nobody ever writes log base e, right? Because we have an abbreviation for that. We call it the natural log. So we get the natural log of m over the natural log of b. So if you're working with a problem and you need it to be in terms of natural logs, so natural logs are a little bit easier to work with, you can always divide by ln b. So just a summary of those properties then. If you got two positive numbers, you're taking the log of the product, it's the sum of the logs, right? That's because the exponent of the product is the sum of the two exponents, and logs are exponents. That's the product rule. If you're taking the quotient, the log of the quotient, that's the difference of the logs, because the exponent on a quotient would be the difference of the two exponents. If you have the log of a power, the power can come down in front, and we have this change of base property. If you want to change the base, you can take the log in the new base, but you have to take the log of the old base in the new base. In particular, if you wanted to change to base e, that would say you take the natural log of whatever you were taking the log of, but you divide by the natural log of the base that you don't want to have to use. This now is a constant, right? So the natural log of x varies with x, but the natural log of a is just the old base. That's just a constant.